Herb, we make and sell the best health and wellness products on the market because we know what's inside every bottle matters, like the vitamins you and your family take to play longer and stronger, but also even stronger. We care what's actually inside the bottles that make up your beauty routine or routines. And unlike the rest, we care enough to test and verify. We ensure that what you find in every bottle is what's supposed to be there. And
You're not a dish. You're a man.
Welcome to Study Session Tuesday here on Cyber Insecurity. We're starting a new series, Intro to Python. Thank you for joining us. My name is Brent Eskridge. I want to thank Neil for letting me take control of the stream for these study sessions. We'll probably quickly find out if that was a wise decision or a learning experience and what not to do. Just so you guys know, my background, I've been a software developer for about 6 years. After that, I was a computer science professor for 17 years, and now I'm a threat intelligence analyst. You can find out my socials there with !Brent in chat. If you want to connect with me on LinkedIn, that'd be great. All I want you to do is send me a note to let me know what you're trying to get out of these streams. So I want to thank our moderators for being here. We have a zero tolerance policy on toxicity on the Cyber Insecurity channel. We want this to be a positive learning environment for everyone, and moderators are here to ensure that that happens. If you're put out on a timeout or a ban, talk to the moderators about it on Discord. I don't have anything to do with that. They're here, not here to stifle chat. They're here to ensure that you get an opportunity to learn and ask questions. I welcome questions throughout the study session. That's how you learn, but there are a few rules. First, ask your question once and only once. The moderators do see your questions and will send them to me. Now, if I see them, that's another matter, but I'll be trying to pay attention. I'm going to try and answer the questions as quickly as I can. Second, there are some questions I can't answer on stream, such as my Python installation is broken or my code isn't working, what's going on. So because of this format, I really can't answer those sorts of questions. But if you have one of those types of questions, please ask it in Discord. We've set up a special Python study room that you can ask questions even when the stream is over. I've got it set up so I'll get notifications whenever there's a new post in there. So I'm happy to answer questions that you may have, and the rest of the community will jump in. So let me give you a little bit of an overview on what this study session is going to be. So this is based on content from my Intro to Computer Science course when I taught as a professor. So I taught the course about 17 times over my 10 years as a professor. It's the same content. It's just been repackaged, except for the fact that you don't have to take tests and you don't get crippling debt. So if you want those things, talk to me and we can work some of that out. There are no prerequisites for knowledge for this course. I assume that, or this study session, I'm not assuming you know anything. All I really need you to have is Python installed and a willingness to learn. So I will have one little caveat. I'm going to use probably a few math examples as we go through the series. That's just because math problems are easy to define. We can set them up, and they're not the dreaded word problem. So they're a little bit easier to start off with. But don't worry about that if you have some problems. I've set up a GitHub repository with all of the content. You can use !Intro to Python, and you'll be able to get all of the information there. The GitHub repository has links to Jupyter notebooks, with all of the study notes. It has links to a document that's got some supplementary resources, some exercises if you really want to do homework on your own. I've got that all set up for you. I'm going to be going through the book Think Python. It's linked there on the GitHub. It's a fantastic book. It's got a lot of good examples. It's got some exercises, and it presents things really well. One of the great things about it is you can download it for free as a PDF. However, if you'd like to support the author, I'm not affiliated with him in any way. I just think he's written a great book. Feel free to go buy it from your favorite bookstore. So the series is about 12 weeks, unless there's demand to go longer. But I usually go through about the first 12 chapters. So we're going to try and go through a chapter a week, although tonight we're going to probably go through the first 2 chapters since the first chapter is pretty easy. So we'll try and hit a chapter a week just so you can kind of keep up and plan for that. After that, you have a foundation that's strong enough so you can continue to learn on your own. So this kind of gets you over those initial humps. So you've got a foundation where you can program in Python and you can tackle some of the more complex concepts. So cyber insecurity, those of you that frequent the stream know that we like our cyber secrets here. So I'm going to start off with a cyber secret. Python isn't the primary learning objective. So I know everyone is now leaving the stream because that's what you came for. But one of the things that I've learned when I've tried to teach people how to program is that the algorithm part is much more difficult than the programming part. So learning to create an algorithm to solve a problem is really the technical challenge. I've worked with numbers of students that always blamed the code, but what we found out when we dove into it deeper was they either didn't understand the problem or they didn't understand their solution. So one of the things that we're going to really emphasize here in these study sessions are, can you analyze a problem? Can you figure out an algorithm? So we want you to think in terms of algorithms. Jumping right into code is a problem. It's really hard to succeed. I've been programming for a long time and I still want to do it. So it's a habit you're going to have to break. So I used to tell students that a program is proof that your solution works. So what that means is you have to have a solution before you can write a program. So that's what we're going to work on. We're going to do a little bit of it tonight, but we're going to hit some basics of Python, so we won't dive too much into algorithms with code. So you might be asking, what is an algorithm? Well, it's a step-by-step procedure for accomplishing some task. Usually those steps, we want them to be very atomic, precise instructions. They are not code. So the algorithms we're going to work with are written in, my case, English. If your first language is something else, feel free to write it in that. But we're going to be using English. So I think this is so important. What I'm going to do is I'm going to post on Twitter, probably Monday, before every stream, an algorithm challenge that I want you to work on and try and figure out an algorithm. And I'm going to spend the first few minutes out of every study session working on one of those algorithms. Now, the thing is, I'm going to give you algorithms that you don't yet have the knowledge in Python to complete it. And that's intentional, because if you knew how to program it in Python, you'd be tempted to jump straight into Python and start coding. But since you don't have the Python yet to learn how to do it, you won't be tempted to jump into programs. So I really want you to work on getting the algorithm set up. So to start off tonight, we're going to work on an algorithm. I've asked someone to write an algorithm to tie their shoes. So we've got a special guest. I think you may have heard of him. Hey, Neil, how are you?
Hey, Brent, thanks for having me.
So thank you for being my guinea pig. So this is an exercise I do every year to start off this semester. It usually gets a few chuckles, and I lure students into staying into the class long enough so they can't drop. What we're going to do here is I asked you the other day to come up with an algorithm for tying your shoes. I said just spend about 5-10 minutes. I don't want you to spend a long time and be over-prepared. So I actually have a pair of shoes here ready to go. So
all right.
Now, other than me telling you to tie your shoes, we haven't coordinated anything. So Have at it. So just kind of go and give me your instructions, and we'll see what's going on.
All right. So I think I'm ready for this. Let's see what we can do here. First of all, take your left hand, move the left shoe out of the camera view.
Okay.
All right, so let's just lift the right shoe. Awesome, fantastic. Take the right shoelace. Oh, see, you moved the shoe. I didn't tell you to move the shoe.
You didn't tell me how to have the shoe in the first place. You made an assumption.
Put the shoe back over the way it was before.
That wasn't
face
part
down.
of your instructions.
Oh,
you can't
changed
go change
it
the
on
program
me.
in the middle. Go ahead.
Oh my God, here we go. All right, now I got to do the shoe backwards. Shoot.
No, just give me your instructions. What were your instructions?
Right. Take the shoe, place it back where the bottom of the shoe is face down on the table.
Okay. So I'm sorry, I had to do this echo. All right. So read that. Say that again.
Take the shoe.
Okay.
And put it so that the bottom of the shoe is face down on the table. There we go. Awesome. Fantastic. Thank you very much. Now, in your right hand, grab a hold of the right shoelace. All right. Can you move your hand so I can see it in the screen? Okay, thank you. All right. I want you to take in your right hand the right shoelace, and I want you to make a loop about 1.5 inches in diameter and pinch the intersection of the shoelace with your index and your thumb finger. Awesome. Now, I want you to do the exact same thing with your left hand and the left shoelace. Okay. All right, here we go. Shoot. Take your right hand, and I want you to cross that shoelace over the top of the left shoelace. Nope, not the left hand, the left shoelace. The left shoelace. There we go. Awesome. Fantastic. Thank you. Now, take your right hand and push the loop through the underside of where the shoelaces cross. All right. Now, I want you to take the shoelace. Hold on. Take the shoelace really quick. Wrap it around your neck and pull really, really tight. Can you do that? I'm kidding.
Not on camera, no.
This is much harder than I envisioned it in my head. Much harder than I envisioned it in my head. All right, start over from scratch. All right. Let's try this again. Take your right hand and pinch the tip of the shoelace and pull it tight. The tip of the right shoelace. Okay. Just your thumb and your index finger. It's the only thing I want you to hold it with. Awesome. Do the exact same thing with your left hand. Awesome. Fantastic. With the left shoelace of the shoe that you're on. Awesome. Okay. God, how do I describe to you this wrapping procedure? Create an X with the shoelace so that the center of the X is where the shoelaces are touching in the center. In the center of the shoelaces that are exposed. Okay, all right, that's a little bit better. I don't like your hand positions on that one. Can you inverse your hand positions? Oh, okay. Well, I guess that's a literal programmer for you right there. I guess I asked for that one. Okay, I give up, Brent. I give up. That was way more than 5 minutes. I clearly can't do this. Can you explain to me why you had me do this and embarrass myself on camera?
Yes. So the challenge here is that we're not used to doing this, right? Can everybody hear me? Yeah. Okay. We're not used to doing it.
Brent.
We're not used to doing this. Working with audio problems. We're not used to doing this, right? This is not something that we are used to doing in English, right? Natural languages. So English is a natural language. The challenge here is natural languages are ambiguous. So for example, the word hot, what does that mean? It can mean temperature hot. It can mean, oh, that's cool, right? Neat. Then we also have the word cool. That can mean cold or cool. So there's a lot of ambiguity in the English language. And that's one of the challenges, because there's a lot of, you know what I mean, right? When you were giving me instructions, you had the assumption that I knew what you meant.
Yeah.
And that we were coming from the same standpoint, and that you knew and I knew, what we were trying to do. And so the challenge here is computers are stupid. They only make the mistakes you tell them to. And so the challenge here is that we're trying to translate a problem that's given in a natural language, right? Because all the interesting problems are word problems, and everyone hates a word problem. And we're trying to translate that into a programming language, which is called a formal language. And so the challenge here is, if we jump straight into code, we're going from a problem in natural language to a formal language, and we're skipping that all-important step of analyzing the problem and trying to figure out a solution, where we're trying to write the program on the fly. So that's why algorithms are important, because we're skipping that step. It's like, would you want to buy a house where a builder showed up at a lot and said, I'm going to build a house, and just started putting it together? Of course not, because there would be all sorts of problems, because you have to think about these things ahead of time. And that's what we're going to do with algorithms. So every time we write a program here, we're going to go through and we're going to write comments, and we're going to make sure we understand the problem and our solution before we ever start writing in code.
Makes sense. Makes sense.
All right. Thank you for joining us, Neil, and allowing me to make fun of you with you. So.
I appreciate it. Hey, listen, thank you so very much for doing this, and thank you all for tuning in. And I hope you get so much out of this. Thank you so much, Brent.
Thank you. Bye. See you later. All right. So now that we've kind of established why, now that we've established why algorithms are important, let's start talking a little bit about Python. So like I said, we're not going to have an opportunity to dive right into some big algorithms here tonight. We're going to hit some basics of Python, but I do want to get things going a little bit. So let me take a look here. All right, so what we're going to do, we're going to use just the default development environment in Python. This is called idle. It is not a fancy IDE. For those of you who know integrated development environment, for those of you who've done programming before, it's not fancy at all, but it does get the job done. All right, so the idea here is it comes built in when you install Python, so it's ready. We don't have to install anything else. We don't have to configure it. It's all ready to go. All right, so when you first start idle, you get the shell here. So this shell basically it allows you to input commands straight into Python. So Python is what is called an interpreted language. So you don't compile the programs like you would with Java or C or C++. So I can do some simple commands like this. So I can add, I can print hello, things like that, and it will just run. All right, so we can do some simple commands here. Now, the challenge is that it doesn't save this. So if we want to save it, what we need to do is we need to open a new file. All right, so this is where we can write our Python programs and save them to be able to be run later. All right, so we can do some things like put some comments in here, which we'll talk about in a minute. But now I can do things like print hello here. And then what I need to do is save it. I'm just going to save it in my main directory here. And we want to end it in .py. So it's a Python file that will tell the operating system whenever I want to run this, to run it using Python. All right. So I can click run, and we'll see the output over here. All right. So one of the things is you need to make sure that you know where these files are. We're going to be doing some exercises later on in the series that require you to put files in this directory. So when we start reading files, things like that, you want to know where this directory is. So I suggest you organize it, put it in a directory somewhere. Also, whenever you want to run or open up a file in idle, you need to make sure that you open it with idle. If you double click on it, your operating system will just run it. I'm running a virtual machine of Linux right here. And so if I brought this up and tried to run, click on this, in this case, it opens it up. It doesn't open it in idle. In Windows, it will actually just run it. And you'll see a window pop up. It will print hello, and then it will close. All right. So let's get started. We're going to do a little bit of Python basics here. If you've programmed before, some of this is probably going to be old hat to you, but I want to make sure that everyone has a strong foundation before we start diving into later chapters. So one of the big things whenever you program is that we've got variables. So variables will hold pieces of information that we're going to call values. So the values, these are our basic pieces of data. Values are data. We're going to talk about three main types of data here to start off. The first one is integer data. So the number 17 is an integer. So think whole number. So I can do this, and we'll explain what this is here in a minute. So you can see that it says it's an int. So someone's asked a question for me to go back and see how I created file. Also, a virtual environment. Or a virtual machine. Basically, I'm running a virtual machine of Linux here. So this is a Windows machine, but I do all of my development in Linux. And so I fired up Linux. So if I want to create a new file here, all I do is new and file, and then you can just save it as a .py file wherever you want. Okay, so that way you can get started. And once it's saved, it will allow you to run it. You have to save the file before it will run it because it saves it on the file system, and underneath Python will run the file that you have saved. All right, oops, that's data. All right, so next, the next piece of type of data we have is what's called a float. This gets back to how the information is actually stored in a computer. It's called a floating point. I'm not going to get into the details here. There's lots of resources on the internet that you can figure out how it works. Basically, think of this as decimals. All right, so this is a decimal here, so it's going to call it a float. All right, so now notice to us, these are the same number. Right? 17 is 17, even if I put a 0.0 at the end. To a computer, it's different. Now, Python will actually be able to kind of move around, and we can switch it back and forth, but it sees that these values are different, and we'll see that here in a minute. So the last data type that we're going to talk about, so this is an int, and this is a float. The last one we're going to talk about is a string. There's other data types, but these will do well for us for a while here. All right, so I've got a string here. And so this is a string. Python sees these as completely different variables. All right, so there's some questions here. Whoops, I don't like spaces there. Does Python care about spacing? As long as it's not in a string, Python is okay with it. This gets to where you want to have what's called a coding convention. Think about coding conventions are just kind of the rules in which you organize your code. So Python doesn't care, so I could write this without any spaces if I wanted to. I could put a whole bunch of spaces if I want to. I'm always going to fall down on the side of readability. So I've read a great quote once that said, programs are read by people far more often than they're read by computers. And so I want to make code as easy to understand as I can. So for those of you that have programmed before, you'll understand this sentiment. I've written code before where I come back 2 months later and I look at it and say, who's the idiot that wrote this code? I don't know what's going on. And the idiot was me. So I'm always going to try and write code so it is the most understandable, because I don't want to have to waste time and effort trying to figure it out if I can format it to make it easier to understand, right? There's also a question of, do you need a single quote or double quotes? Python really doesn't care. Other programming languages do. So other programming languages, Java, for example, I've done a lot in Java. A single quote is only for a single character, like a single letter, and double quotes are for strings. Python, you can use a double quote or a single quote. Coding convention, so the standard for Python is to use a single quote, which is very hard for me because I've done a lot of programming in Java and C++, and so they use double quotes there. But Python, kind of the convention is a single quote, but you can use whatever you want. Whatever you do, just make sure it's consistent. All right? So these are the 3 data types that we're going to talk about here to start off with. I see there's another question about libraries, things like that. We are going to get to libraries. I don't want to jump ahead too much, but I think that's in chapter 4. We're going to install some libraries and go with that. So we're going to hit the basics right now, so we can just kind of get through and make sure that we've got a solid foundation. All right. So we have these values associated with a data type. We don't want to have just these numbers running around. These are called literals, meaning I literally mean 17. So we're going to be able to store them in variables. But I do want to remind you, I mentioned this, Python sees these as completely different numbers. We read these as the same, but Python sees these different. In fact, it doesn't even know that this is a number, right? It just sees that it's a string. We interpret it as a number, but Python doesn't. So we're going to work on this as we go through, but just remember that they're completely separate. No, Python is not a strict language, so it's very loose. So there is a question there from Claw. No, it's a weakly typed language. So if you know programming, you know what that means. If you don't know, then ignore it. You don't need to know it. Okay. So we want to be able to put these different values into a variable. So think of a variable as just a bucket where we can store it. So the important thing is a variable is a name or a label for a value, right? This label or name has no inherent meaning in Python, right? So I can do something like this. So I'm going to count something, right? So 55, that's the count. I could also have a size that's 42.0. All right? So basically, these variables are just a label for the value. I could name a variable like that. All right? Now, it's not a good variable name because it's just garbage. And so that gets into, we want to name our variables the right thing and things like that, which we'll talk about. But it has no inherent meaning to Python. In fact, once Python compiles this into executable code, those names disappear, and it's just a place in memory where the value is being stored. All right? So just know that Python doesn't care what that name is. It's not going to associate any meaning with it. All right? But it does hold that value. So if I want to see, for example, what data type is in count, can try this, and we can see it's an int. All right, because I stored 55. So I'm going to ask you a question here real quick. I'm going to give you a second to try it on your computer. What data type is size? Give you a moment. If you said float, you're right. So I'm going to pause ever so briefly as we go through. One of the great things about this programming stuff is you can try it on your own. So I highly recommend that you have a development environment up and running. You're not going to blow up your computer. It's fine. So just try it out. That's one of the great things. Okay. All right. It looks like I'm caught up on questions. So let's go on to the next section. I'm going to actually see if I can move this up a little bit. So I'm not completely covering up everything. All right. So we've talked about some different data types. We've talked about some variables. So let's talk about what we want to name them. Now, if you are students in my class, I would have rules that say you have to follow my coding conventions. Every company, every person has their own coding conventions. The nice thing, when I was a professor, I was in charge, so I got to tell them, students what to use. So that's not the case here, so you get to choose your coding convention. The important thing is that you be consistent. So it makes code look a lot cleaner. So I'm going to kind of put professor mentor hat on here for a moment. If you're going to be trying to show your code to help get a job or be professional or something like that, think of it as when you would write a paper, right? You'd want to make sure the margins are set, that you have consistent font, that your spelling is correct, things like that. It just shows that you put effort into it. The same thing with programming, putting comments, naming things appropriately. It shows some professionalism in the code. So, I don't want to harp on that too much, but it is an important thing. So I'll let you know that I interviewed with Google once because they actually looked at some GitHub repositories. And so they looked at it. And so that can get you interviews. I know that there's Google managers that have scripts that run through GitHub repositories and look for code that looks good, follows conventions, does some cool stuff, things like that. So that sort of thing can be a good thing. So as far as variable names, X, Y, and Z, I see a lot of programs with X, Y, and Z. Unless you're doing something with 3D points where X, Y, and Z are, in the coordinate system, don't use them, right? They're not very meaningful. So Python does have some rules for variable names. They can be arbitrarily long. They can contain letters, numbers, and underscores, but it has to begin with a letter. So as you see, I'm going to try and be very consistent with my variable naming conventions. And so you'll see that the standard for Python is usually lowercase. There's some situations we'll use uppercase, and I'll address it when we get there. And then if your variable name has multiple words, you separate them with an underscore. So one thing to note, Python is case sensitive. So if I want to do, actually that's not a good, a max value of 55 and a max value 55, those are separate variables to Python. So it doesn't have any inherent meaning, but the character capital M is different than the character lowercase m. So if you know your ASCII values, then you'll know that those are actually separate character codes inside the computer. All right. There's a question here about comments. I'm going to hit the comments here in just a minute, so I'll get to that. If you ever give an illegal name, Python will complain at you saying it's a syntax error. So for example, what I was trying to do with max 55, you can see I do this. It's not going to complain at the moment, but this is what's called a keyword. It means something special in Python, so we're not going to do it. So I think the book Think Python has some of those keywords listed in it. So it's basically just you want to avoid those. All right. Okay, so I'm just checking to make sure we don't have any questions on variables. We can go on. So now we've got variables. So let's think of those variables as words, right? So if we were going to be speaking, we'd want to take those words and compile them into sentences so that they actually mean something. Well, in Python and in programming language, the sentence is a statement. So you can think of that as a sentence. All right. So it's a unit of code that Python interpreter can execute. Usually it's a single line of code. It can be more depending on the statement. And when we have a script, so like this is a sequence of statements. Right? So think of this as we're now telling a story. We're starting to write some sentences and put them together into paragraphs, and it's going to tell a story tell the computer what to do. All right. Now, we've talked about variables. Those are some words. Those are usually nouns. So, think back to elementary school. If we've got nouns, we need some verbs to do some things. And so that's where things like operators come in. All right. And we're going to talk about functions, and functions will be the next chapter. But operators, they're special symbols that in this case represent computations. Okay, so the easy ones to start off with are the basic mathematical ones. All right, so we have 3 plus 4. So plus would be our operator for addition. All right, so we've got 3 and 4. So in this case, so our operator is plus, and then we have operands. So these are the things the operator works on, are 3 and 4. All right, so addition is what we call a binary operator. We're adding 2 things, so that's why we have 2 numbers. All right, we also have minus for subtraction. So I'll print this here real quick. We also have multiplication. Now, we can't use an X here like we would in math, just because X could mean lots of different things. It's a normal character we'd use in a word. So what we use is we use an asterisk. It means multiplication. All right, so it should become second nature to you when you see it. Now, for me, it looks odd to write an X for multiplication. I've been just doing this so much. All right, then the last one, the normal ones we have is we have the slash, and that's for division. All right, so let's run this. And so we get 0.75. Now, in older versions of Python, so versions 2 and on, Python division worked a little bit different, and we're going to need to use this to our benefit at some point. But there is a special division operator, //. This does what's called floor division. So I'm going to run it here real quick, and then I'm going to explain it. So we can see here at the end that we just get 3. But if I were to use regular division, I'd get that third there, right? And we'll talk about this in a minute, the 5 here. So what this does is it's called floor division. So think back to elementary school when you were learning how to divide. You would divide and then you'd get a number and a remainder, right? So what this does is this says how many times 3 goes into 10. And then we're just going to throw away the remainder. We're going to throw away that decimal point, right? We'll talk about how we can get that decimal point and how we can get that remainder later. But for right now, floor division just throws that away and we're left with an integer. All right. Now, this is an interesting one. We've got a 5. So, if you know your math, you know that that should be 3's all the way out to infinity. I have a nice computer, but unfortunately, I don't have infinite memory. I don't know that that's even possible, although, you could download more memory off the internet. So this gets back to floating point representation, how the number is represented in the computer. All of these floating point numbers, these decimals, are approximations. So even up here, where I've got 0.75, this one's probably an easy one because it's a power of 2. But if I were to do 0.1, it's probably 0.1 with a whole bunch of zeros and then maybe a 1 somewhere. Or 0.999999 with a whole bunch of them. It's not going to be exact. So as we start working in Python more, one of the things you do need to be aware of is that all the floating point numbers are approximations. So whenever we get to some tests and you want to say if it equals something, you need to be careful because it's rare for it to be exactly, because there's going to be some error, 12th decimal place, something like that. All right? So something to be aware of. Now, we've talked about some data types. I've got integer here, and I divide, and we're left with a float. All right? So what happens is, as we do some of these operators, what Python will do is it will convert the data from one data type to another. It's very important to understand what data type the data is in. So if we are doing this, you can see we've got addition, subtraction, multiplication. All of these are fine. They're integer and the output is an integer. So what happens is if both the operands are integer, the output will be integer, unless we've got division here. Division is the weird one. You're going to get a float. But if we mix the data types, so I've got 3 times 4.0. Essentially, to you and I, it's the same problem as 3 times 4. But to Python, it's different because this is a float. So what it's going to do is it's going to say, I can't multiply these two. So what it's going to do is it's going to take the 3 and turn it into a float and then multiply it. And so the result is going to be a float here. Okay? So the important thing is this is called promoting. So think of these as they're different size buckets, right? It doesn't know that this is a 0 going into it, and it's saying, Python's saying, there may be some decimal stuff afterwards. I don't want to lose that, so I'm going to promote this from an integer to a floating point. All right, so floating point numbers, they can represent much larger numbers and much smaller numbers than ints, but they're approximations. They're not exact. So what we need to take that into account. But Python, what it'll do is it'll convert both of these to a float and then go on. All right, so check here, see if we have any questions. Seeing no questions, I think we're good. So we've got sentences, which is a statement. We've got some nouns, which are the variables, verb, which are the operands, and we're going to put them together into phrases using expressions. Okay, so think of this as a phrase. It's a combination of values, variables, and operators. A variable itself can be an expression. So what Python will do is it's going to go and interpret these expressions. So up here, it interpreted count and said, oh, that's 55. And then as we'll talk about, it passes it to this function. It evaluates that function and then says, oh, okay, I'm going to take the result from that and print it out. So think of it as it kind of goes, if you're familiar with math, PEMDAS, so parenthesis, exponent, multiplication, division, addition, and subtraction. So Python does that same sort of thing as it starts to evaluate these. All right, so this is called rules of precedence. So let me show you an example here. So I have right? So I've got a mathematical expression here. Now, if you remember your PEMDAS, you'll remember it says, I need to do this part first because it's in parentheses. Python follows those same rules. So it evaluates the expression and says, I can't divide by the 2 here and then multiply by the 3. I've got to do this part first, right? So Python follows those exact same rules. So once, if you remember your algebra, you should be fine, right? So we can print it and go, right? So if it were to do it another way, we'd divide the 1 by 2, get a 0.5, and then multiply it by this, so we'd be about 1.7. You can see that's not the case because it's multiplying the 3.14159 by 2, then using that to divide 1 by that number. All right? Okay, I see a question coming in here real quick. So will this one, okay, so let me go back here real quick. The floor division is always exact because it's going to end in an integer. It's just throwing away decimal, all right? The 10 divided by 3 will always be an approximation because of the way floating point numbers are represented in a programming language, right? Now, obviously, this can be a problem, right? If you're like a bank and you don't want to have those fractions. For those of you that are old enough, you could remember Superman 3, where this was kind of the whole conceit that they got those fractions of pennies and put it together. More modern one is the movie Office Space. Those fractions of pennies are running around. So obviously that's not a good deal for banks. And so what they do is they find other ways to do it. So instead of working with cents, dollars with pennies that are fractions, they just make everything whole numbers. Some programming languages do have specific types of numbers with decimals that are exact. Those are special, and you have to, they don't work with the normal operators here. You have to write them and build a lot of functionality into a programming language to handle that. All right. So there will always be approximations. Now, it may be that the approximation is good enough, right? So there's another data type that in other programming languages called a double, which doubles the size of a float. And so you can get very precise. For the most part, that's accurate enough. But it always may be off a little bit, so you just need to be aware of that when you're comparing numbers. All right. So now that we've got an idea on some expressions, and we've talked about operators, we talked about these operators with ints and floats. But if you remember, there was a third data type we introduced called a string. All right. Now, this string, it's not a number, even if we write it as like the number 17 I had in there. So I can't say 17 plus 3 and hope to get 20 out of it. It's going to go different. We came up with 173. What this is going to do, these are some string operations. So these operators work a little different on strings than they do with numbers. In this case, plus is what's called concatenation. Concatenation. So big word there. So you usually abbreviate it as just concat. But the idea is it's going to take the 17 and the 3 and slam them together into one string. Right? If I did it with a different data type, like 17 and 3, Python's going to complain at me and say, I don't know how to add, concatenate an int with a string, right? It's not even trying to convert it back, all right? And the interesting thing is, when we're doing this, you and I see this 173 and we interpret it as a number. But let me take it here and show you when we do type, Python's not seeing this as a number. It sees it as a string. So you and I interpret it as a number, but Python is interpreting as a string. Again, remember what kind of data types your data is. That's very important because if you forget, then you're going to get some weird output and not know what's happening. All right, so very important. We can't use subtraction. We can't use division with string, but we can use multiplication if we're careful. So for example, I could say, so I can do law *3, and what that will do is it will repeat law 3 times. So we've got law, law, law. All right. Now, I can't use a float, right? Because it doesn't make sense to give half of law. It's going to complain at that. So you can only use an integer, all right? But you can multiply a string by an integer, and what it does is it repeats that string however many times you specify, right? Not very common, but you can do that. All right, so we've gone through some of these expressions. We've gone through statements, operators, and variables. Let me talk a little bit about comments. So you've seen I've written some comments in here. Comments are incredibly important. Don't underestimate the value. Most of the time, well, pretty much everybody hates writing comments, right? I have forced myself to write comments. My first real programming job was for a government contractor. They were really long projects, 10-year projects, and they were very strict on comments because someone else may be working on the program later. And I've heard a good quote: comment your code such that if the person who takes over your code after you is a homicidal maniac and they know your home address, they're happy with you, right? So I had a student that hated writing comments in school. He hated it. But when he went to graduate school and came back and talked to me, he said, students have asked me to help them with their code, and I look at it and they don't have comments and they don't follow coding conventions. The code's all over the place and it's really hard to understand. So I have evidence from students that comments and things do actually help. All right. So comments are a way to add notes to your program. Comments are going to tell you why, right? Code tells you how. Comments are going to tell you why. Why am I doing it like this? Why did I decide to approach the problem this way? If you're finding an algorithm online or a way of doing it, throw the URL into a comment, right? It only helps so you can go back later and learn. So it's explaining what's going on. So I tell students that what I'd like to see is if I could rip out all of your code and just leave the comments, I still know what your code does. I know why it does it, and I get a sense of how it does it, even though the code really says the how. All right? So the code really explains how if you've chosen good variable names. All right? So let me give you an example. So this is a poor example. All right? So I'm going to go up here. So here's my comment. It's calculate it. And I'm going to say y equals 2 and x equals 2 times 3.14 times y. If you know your math, you probably have an idea of what's going on. But let me show you a good example. Yeah, we'll do 2. All right. Now, if you were to read this, and we can put our comment in here that says, calculate the circumference of a circle. So I'm not really saying why here, but this is a simple example. You get the idea. So we could say because something, right? But variable names, I've chosen appropriate variable names. This code is far easier to understand than this code. Now, Python doesn't care between the two. It'll execute them both the same, right? So the idea here is, remember, code is read by humans far more than it is by people. So we want the code to be readable by people, namely you, the developer, so you don't get confused by your own code. Trust me, it happens. All right? So this code is much easier to understand. There's a lot of ways that you can comment code. So, Claude, this is going to go back to your question you had. Yes, you can put comments after it. So I could say, the answer is 42, and I can put a comment at the end. All right. So anything after the pound sign will be ignored. All right. And a lot of people write comments like this. The book Think Python even demonstrates comments like this. I personally don't care for these sorts of comments. It's a personal preference because I would much rather have it above the code it's commenting so I can read the comment and then go. One of the challenges, it's not that big a deal here, but just imagine if this were a really long line of code and the comment goes off to the side like this. Then I'm having to, scroll over, find ways to actually see this. And I can't do that, all right? I know a lot of people have ultra wide monitors. I've got one, and you love to do everything full screen and just go. But that's not always, practical. You may not be able to do that given how you're looking at the file, right? So while you can do it, it's a personal preference. I choose not to, but that's me. And again, I'm coming at it from a perspective of, for 17 years, I tried to teach students how to program, and anything that I could do to reduce confusion, I went for it. So, and I was the professor, I could tell them to do it. So the idea is you want to build up those habits. So I have a habit now of commenting my code. So even if it's throwaway code that no one will ever see, I write comments because it's a habit for me. And when you're starting to program, if you build on those habits to begin with, then you'll stick with it as you go. So it's not fun. Comments are never exciting, but it makes it easier in the long run. All right. So that's the end of chapter 2. I'm going to wrap it up here in a few minutes. There is one more question. Mohammed asked, comparing C and Java to Python. Not necessarily going to go into that. The first chapter of the book does dive into it. So Java and C, Java to some extent, they're compiled languages. Java does some weird stuff with the Java virtual machine. But Python is an interpreted language, which means it's run by scripts. So it's slower, but it makes up for that with all the libraries that are pre-compiled. So I don't know that there's anything that you can't do in Python. Python is a fantastic language for people who want to program but are not programmers, and that comes from all the libraries. I spent some time in a biology lab. The biologists all programmed in Python, and they used libraries for everything. So that's the real benefit. So it's a great learning language, which is why we're using it. All right, I think I've made it through all the questions. I want to thank everyone for joining me. We had a couple of audio hiccups here, and I appreciate you kind of bearing with me as we go through it. Remember to follow me on Twitter. I'm going to post on Monday the algorithm for next week, and we'll spend the first few minutes. I'm going to work through and walk through the algorithm. We're going to talk about the steps. It's not going to be tying a shoe, but it will be all the algorithms I give you will be ones that you could complete with pencil and paper. That if I asked you to do it, you could do it. So it's not a matter of the problem's too difficult. It's that we've got to get in the habit and the practice of being able to take those problems and think through and come up with a solution. So next week, we're going to do that. I'll post it on Twitter. And we'll also start jumping into chapter 3, where we're going to introduce functions. So we're going to talk about how they work. And then we're going to start writing a few of our own functions. We'll also talk about, there was a question earlier about packages and libraries. We are going to touch a little bit on the math library and be able to pull that in. All right. Thank you everyone for joining me. I appreciate it. And I hope you have a good week.